Okay, so let's have a look at example 27. It says here, let's solve the equation 2 sine squared theta equals cos theta plus 1 over the domain 0 to 2 pi. So we've got the equation 2 sine squared theta equals cos theta plus 1. Now the square is very reminiscent of the trick in methods where you let a be sine and then you can get a quadratic equation and solve it that way. But because we've got two different trig functions, a sine and a cosine, that's the annoying part. So if we can rearrange or somehow reorganize so that we get the whole equation in terms of either all sine or all cos, then life will be great. Now, because of this sine squared, it'll probably be easier to rearrange in terms of cos, because sine squared plus cos squared equals 1. So if we rearrange it, we get sine squared is 1 minus cos squared. So let's do that. So this we can rearrange to 1 minus cos squared theta equals cos theta plus 1. Why? Because we are using the fact that sine squared theta plus cos squared theta equals to 1. AKA we were using the rearranged version, which is sine squared equals 1 minus cos squared theta. So if we expand the bracket on the left hand side, we get 2 minus 2 cos squared theta equals cos theta plus 1. Let's rearrange so we get a 0 equal stuff. So we get 0 equals 2 cos squared theta plus cos theta plus 1 minus 2 gives us a negative 1. So this equation now is very reminiscent of the trig equations that we've solved in methods. So the trick was let A, or let any letter you choose to be cos theta. Then we get the quadratic equation 2a squared plus a minus 1. If we can factorize this, we get 2a minus 1 and a plus 1, using your favorite methods of factorizing. Using null factor law, we get that either 2a minus 1 equals 0 or a plus 1 equals 0. In other words, a is a half, or we get a is negative 1. Now, we didn't want to solve for a, we actually wanted to solve for cosine. So in other words, cos theta equals a half, or we have cos theta equals negative 1. So let's consider one of the two cases first. Add more space. So let's consider cos theta equals negative 1. Well, that's just going to be our boundary value, isn't it? Because if you look at your CAST diagram or your unit circle, cosine means it's the horizontal value. So you're looking for the point on your unit circle where your x horizontal value is negative 1. And there's exactly 1 point at negative 1 across 0 up, and that angle is at pi. So we have that acute angle is cos inverse of negative 1, which is pi, and in our given domain of 0 to 2 pi, there's only one answer for that. So therefore, theta must only be pi. So then let's consider the other option, which was cos of theta equals a half. So consider cos of theta equals 1/2. Let's look at our quadrants. CAST. We've got cos is positive, so that's either Q1 or Q4. So cos is positive in Q1 and Q4. If we look at the acute angle, that's cos inverse of 1/2. That gives us 60 degrees, or pi on 3. And then if we consider our domain, which is from 0 to 2 pi, the possible answers are at pi on 3 and 2 pi minus pi on 3. In other words, theta must be pi on 3 or 5 pi on 3. So combining that all together, so therefore, over the domain of 0 to 2 pi, we have theta being pi on 3, pi, and 5 pi on 3 as a solution to our equation 2 sine squared equals cos plus 1.